All right, we are starting composite functions. So composite functions are functions that are formed from two or more functions in which the output of one function, the answer, is used as the input for the other function. So we need to go over some terminology first. The composition of f of x and g of x can be written as f of, let me try to do this better. I'm going to zoom in on the notes so you're going to just look at it. F, little o, g of x. F of g of x, or f parentheses g parentheses x, two parentheses to close it out. So the composition of f of x and g of x can be written as f of g of x or f of g of x, and is read as f of g of x. So the little o there basically stands for of. Composition of functions must not be confused with multiplication. That is, f of g of x does not mean f times g of x. So we've talked about that a little bit before when we were talking about operations, and we're continuing here. Make sure you know what we're talking about. We're not talking about multiplication. In general, composition functions will not be commutative. That is, f of g does not usually equal g of f, except in special cases, and we will talk more about those when we get into inverses. The equation of f of g of x is formed when the equation of g of x is substituted into the equation of f of x. So to illustrate how composite functions work, consider the peanut M&M. Everyone knows M&Ms. So think about a peanut M&M. What's put in first? Obviously, a peanut. That's like our x value. What is it surrounded by? Chocolate. Everyone's favorite. That is our function g in this equation. And the last thing we put in is the shell. The candy shell, or our function f. So altogether we have shell surrounding the chocolate, which is surrounding the peanut, and I'm running out of room. Squeeze it in there. Or, if you think about it, f of g of x. F of g of x. When we're solving these types of equations, we go from inside out. So we solve the innermost function first in step 1. We plug the answer from step 1 into the outside function. Excuse me. Sorry. So innermost function, find our answer, plug it into the outside function. So what your output was becomes your new input, and then we solve. So let's look at some examples. So we have f of x is 4 minus x, and we have g of x is x squared plus x. We want to determine each value. So we're going to look at f of g of 2. We start on the inside. We need to find g of 2. And so we're going to plug in this 2 for x in every spot in g of x. So it's going to become 2 squared plus 2, which equals 6. This output becomes our new input for f of x. So now we're finding f of 6, which is 4 minus 6 or negative 2. That's our final answer. So we took what was given, x equal to 2, and we did our composite functions. We worked inside out, and we found our answer. Let's look at g of f of negative 3. So once again, we need to do our inside, which will be f of negative 3. We do that first. That negative 3 is what is replacing x in our function f. So we're going to have 4 minus a negative 3, which gives me 7. So now 7 becomes my new input into my function g of 7. And so that is equal to 7 squared plus 7 because they go in for each value. And so that's going to be 56. And then finally, we have g of 1. So just because we're using the same function twice, that doesn't mean we're going to get the answer we had for the first one. So when we do inside g of 1, and that's 1 squared plus 1, which is just 2. We take that, so now we have to find g of 2. So g of 2 becomes 2 squared plus 2, which gives us 6. So zooming out, you can see all 3 problems. All right, now let's flip over the paper. Now I'm going to get to the next page. We have a couple examples that we want to work on. So we still have the same f of x and g of x values. You can see 4 minus x and x squared plus x. So the difference now is that we do not have a numerical value that we're substituting in. Instead, we're plugging in one function into the other function. So for this first one, for a, we have f of g of x. Well, fortunately, we're already given g of x. We know that g of x is x squared plus x. G of x is x squared plus x. This is now what I plug into f of x. So I go inside out. So now I need to find f of x squared plus x. And so that means in my function f, anywhere that I see an x, I need to plug in x squared plus x now. So this is going to be equal to 4 minus, instead of it being 4 minus x, now it's 4 minus x squared plus x. And that is just going to equal, if after we send this minus sign through to both, and we want to put it in standard form, negative x squared minus x plus 4. That's our final answer. That's f of g of x. Now you're going to see that g of f of x is not going to be the same thing. So we know f of x. We know f of x is 4 minus x. So we are going to plug this into g of x now. So g of x, but actually now we're finding g of 4 minus x. So now in our function g up here, Anywhere you see the x, you got to plug in 4 minus x. So that's going to make this 4 minus x squared plus 4 minus x. So we got some more work to do. Equals. So now we need to square 4 minus x. That means it's 4 minus x times 4 minus x. So don't forget that. Don't just try to square something and forget what squaring actually means. This is where a lot of mistakes are made. So now I'm just rewriting it for our sake. We have 4 minus x squared becomes 4 minus x times 4 minus x, and then I still have plus 4 minus x. So when I solve it, I'm going to use FOIL. First times first, 16. Outside, 4 times negative x, negative 4x. Inside, negative x times 4, negative 4x. Last, negative x times negative x plus x squared, and then I still have this plus 4 and a minus x. And I want to put these in standard form. So I'm going to put the x squared first, so now I'm just combining like terms, x squared, and then I have 3 different x's, negative 4x, and negative x. So it's going to be minus 9x, and then I have a 16 and a 4, plus 20. And that's my final answer for B. And then C, g of x. So just like before, on the front of the page when we had the same thing twice, I know g of x is x squared plus x. So I'm just going to rewrite that. That's given to us, because I just want you to see what we do with it. We take this output and it becomes our new input. So now we're doing g of x squared plus x. And that is equal to what? Well, now we have to plug in x squared plus x anytime we see an x in my g of x. So this is equal to, so g of x is x squared plus x. So now anytime I see an x, I need to plug in x squared plus x. So I'm going to plug in x squared plus x, the quantity squared, plus x squared plus x. A little confusing, but just stay with me. So now, just like before, we need to multiply these through. X squared plus x, if it's squared, first times first, it'd be x squared times x squared. That's an x to the 4th. Then first, outside, x squared times an x, that's an x cubed. Inside, we've got another x cubed. And last, that's an x squared. We're running out of space. I'm going to just keep adding x squared and then plus x. So that's all one step there. It all equals x to the 4th. So what I'm circling in blue, I wrote down below. X to the 4th plus x to the 3rd plus x to the 3rd plus x squared plus x squared plus x. And that will give us standard form x to the 4th plus 2x to the 3rd plus 2x squared, and then if it's going to fit, I don't think it's going to fit, plus x. That's the whole final answer. X to the 4th plus 2x to the 3rd plus 2x squared plus x. And sorry if you can't read that one as well. Maybe I'll write it down here, just so you can see. X to the 4th plus 2x to the 3rd plus 2x squared plus x. There you go.